In this video, we are going to learn about the variant subsystem feature in Simulink introduced in Release R 2010b. Creating multiple variants of a design is essential in many industries to satisfy diverse market needs and customer preferences. This is an automotive powertrain model. Automobile design is very modular and can involve developing variants of a template design for different customer preferences, geographical locations, and so on. The variant model feature introduced in R 2009b enables data-driven selection of design variants at the model level. Here, the referenced model for the controller implements variants based on conditions like horsepower and the vehicle type. In this case, I'm using controller variants called Standard, Adaptive, and High Tech for the different vehicle models determined by the variant conditions. Each design variant is associated with a variant object, and its selection is based on a user-defined condition. The new variant subsystem feature in R 2010b extends this functionality to a subsystem level. Variant subsystems, unlike configurable subsystems, do not need the design variants to be library blocks. More importantly, with variant subsystems, component variants at different levels of the model can be automatically selected based on the same variant object and the same condition. Let us see how you can incorporate design variants using variant subsystems. You can have multiple variants of your design as different subsystems within a variant subsystem. To define the subsystem interface, add the required number of input and output ports. You don't need to physically connect the input and output ports to the subsystem, as Simulink automatically associates the ports for simulation and code generation purposes. Here I have subsystems for the three different variants of the engine overhead cam design. You can use the variant subsystem dialog for creating new variants, associate corresponding conditions to make a variant active, and open a particular variant. Each variant is linked to a variant object and can be selected using data-driven conditions. The same variant object can be used to define a variant subsystem and a variant model, thereby simplifying the implementation of variants at different component levels. Now the model is ready to use the appropriate design variant depending on the value of the control variable in the base workspace. I'm going to set the value of the control variable for horsepower to 300. Vehicle type, which is an object of enumerated data type, is defined here. I'm going to select SUV as vehicle type. Updating the model using Ctrl D updates the model and subsystem variants. Simulink checks to make sure that there exists one and only one active variant corresponding to the control variable data. If the control variables does not satisfy the conditions of any of the variants or satisfy the conditions of more than one variant, the model update stops with an error message. Code is generated for the active variant. You also have the option to generate code for all the variants with preprocessor conditionals. Let us take a look at the generated code with this setting. In the code generation report, you can see the code variants corresponding to the variant models as well as the variant subsystems. You can see the compiler directives like -f and -elsif for the selective compilation of the code variants. This concludes the variant subsystem feature demo.